Okay, question 1. Jerry is 5 years younger than Tom. 2 years later, Tom will be twice as old as Jerry. Find their present ages. So here you want to find their present ages, right? So we can use the letter X to denote the age of either person, right? For example, present age. We use a letter X to denote Tom's present age, X years old. And at the same time, Jerry would be 5 years younger than Tom. So Jerry's present age is X minus 5 years old, right? And we also know that 2 years later, okay, 2 years later, Tom would be X plus 2 years old, right? And at the same time, Jerry would be X minus 5 plus 2 years old, right? Because now it's 2 years later. What else do we know? 2 years later, Tom will be twice as old as Jerry. So that means in 2 years, Tom's age, which is X plus 2, is twice of Jerry's age, which is X minus 5 plus 2, right? So according to this formula, according to this equation, we can find X. Okay, this gives us X equals 8. And what is X here? X is Tom's present age, right? So if you want to find Jerry's present age is X minus 5. So X minus 5 is 3. So Jerry's present age is 3. So now we can make a conclusion. Tom's present age is 8. And Jerry's present age is 3, right? And usually you can always check a result to see if the results are correct, right? So let's take these values back. First of all, Jerry is 5 years younger than Tom. So 3 is 5 years younger than 8, right? Okay, so the first condition is met. 2 years later, Tom would be 10, right? And Jerry would be 5. And Tom will be twice as old as Jerry. So 10 is twice of 5. So the second condition is met. So this result is verified. Okay, any questions? All right, if you don't have any question, let's proceed to the next one. Question 2. Jay's dad is 5 times as old as Jay. After 6 years, dad will be 4 times as old as Jay. Find their present ages. Okay, again, you want to find the ages of both dad and Jay, right? So you need to use a letter X to denote either Jay's age or Jay's dad age. So for example, we use a letter X to denote J's age. So that means present J is X years old. And how about J's dad? J's dad is 5 times as old as J. That means that is 5x years old now, right? After 6 years, what will happen? J will become x plus 6 years old, right? And that will be 5x plus 6 years old. And what else do we know? That will be 4 times as old as J. That means this value, 5x plus 6, is 5 times as old as J, is 5 times x plus 6, right? Okay, and according to this equation, we can solve our x. This gives us 5x plus 6 equals 4x plus 24, right? So this gives us x equals 24 minus 6, which is 18. What is x here? X is J's present age, right? We also want dad's present age, so we need to find 5x. 5x is 90. So here we have these two values here. And the conclusion is J's present age is 18. Dad's present age is 90, right? Okay, have a look at it. Any questions? Okay, next one. Question 3. Louise is 26 years old now, and her daughter is 4 years old now. In how many years will Louise be double her daughter's age? Okay, here you want to find in how many years will Louise be double her daughter's age, right? So we don't know the years, so we can use a letter T to denote the years, and then try to find some equality relationship and solve that equation to get T, right? So here, we can say that let T denote the years taken for Louise. He double her daughter's age. So as long as we can solve T, we will get the final result, right? So what do we know here? Louise is 26 years old now, and her daughter is 4 years old. And after T years, Louise will be 26 plus t years old, right? And her daughter would be 4 plus t years, right? And the requirement is Louise be double her daughter's age. So the value on the left-hand side should be twice of the value on the right-hand side, right? So this is the equality relationship we are looking for, from which we can solve our t. Okay, this means t is 26 minus 8, which gives us 18 years, right? Okay, so conclusion is in 18 years, Louise will be double her daughter's age. Okay, any questions? No? Okay, let's see the next one. Question 4. The sum of the ages of Nicole and Christian is 32. In 2 years, Nicole will be 3 times as old as Christian. How old are they now? Okay, here we want to find their present ages, right? So we can use the letter X to denote either Nicole's age or Christian's age. So present age, I'll write it here. Nicole, for example, here we use X to denote Nicole's present age, X years old. And Christian is 32 minus X years old, right? Because here it says the sum of the ages is 32. So the other person's age is 32 minus X, right? This is present ages. And in 2 years, Nico will be X plus 2 years old, right? Because 2 years has passed. And Christian will be 32 minus X plus 2 years old, right? Again, because 2 years have passed. Also, we know that in 2 years, Nico will be 3 times as old as Christian. So this value here is 3 times of this value, right? Okay, so the relationship is Nico's age, which is X plus 2, is 3 times of Christian's age by then, which is 32 minus X plus 2, right? And from this equality relationship, we can solve our X. Okay, for X equals 100. That means X is 25, right? So X is 25. What is X? X is Nico's present age. Of course, we need Christian's current age. as well, which is 32 minus x, which is 7, right? So now we can make the conclusion. Nico's present age is 25. And Christian's present age is 7, right? Okay, have a look at it. Any questions? Okay, no questions? All right, let's see question 5. Carmen is 12 years older than David. 5 years ago, the sum of their ages was 28. How old are they now? Again, this is a typical age problem. So you want to find their current age, right? So we can use the letter X to denote Carmen or David's present age. So present, for example, we use the letter X to denote David's current age. So presently, David is X years old, and Carmen, how old is Carmen now? Carmen is 12 years older than David. That means Carmen now is X plus 12 years old, right? We also know that 5 years ago, sum of their ages was 28. So 5 years ago, how old were they? How about David? 5 years ago, David was X minus 5 years old, right? Because 5 years ago. And how about Carmen? Now Carmen is X plus 12 years old. So 5 years ago, Carmen was X plus 12 minus 5 years old, right? And it also says the sum of their ages was 28 5 years ago. So that means sum of these two numbers is 28. This means X plus 5 plus X plus 12 minus 5 is 28, right? Okay, so this gives us 2x minus 5 plus 12 is plus 2 equals 28. So this gives us x equals how many? 2x is 26, so x is 13, right? So what is x? The meaning of x is David's present age. So of course, we need to use x plus 12 to find Carmen's present age, which is 25, right? Okay, so we get these two numbers. The conclusion is David's present age is 13, right? And Carmen's present age is 25, right? Again, you can always verify your result by putting them back to the original story, right? Okay, have a look at this question. Are we clear here? Okay, so question 1 to question 5 are all typical age problem, okay? If you are still not familiar with such type of questions, it's better for you to put them in your error book, okay? All right, if you have no questions, let's see question 6. Okay, question 6 and 7 are typical size matching problems. Okay, question 6. The length of a rectangle is 3 times its width. Okay, to solve such questions, it's better to draw a sketch, right? Okay, here we have a rectangle, and we know that the length is 3 times its width. So we can use a letter W to denote its width. And we know that the length of a rectangle is 3 times its width. So length here is 3W, right? So my suggestion is if you are in an exam, it's better to make it clear what's the W here. So let's write this sentence. Let W denote the width of the rectangle. Okay. And we also know that the perimeter of this rectangle is 100 meters. So that means W plus 3W. That's one length plus one width, right? The whole perimeter is twice of this value. And this equals 100 meters. Okay, so this gives us 8W is 100. That means W is 12.5, right? Because it's length, you need to write the unit after this value. The unit is meter. Okay, this is a width. So how about the length? Length is 3 times, right? So this is a length. 3W equals 37.5. Okay, the unit is the same with the perimeter of this rectangle, which is meters. Okay, so the conclusion here is length is 37.5 meters and width is 12.5 meters. Okay, any questions? To make it clear, I think it's better to write the unit here as well. Or it's better to write it after the width here, M. That W denotes the width. Unit is meters of the rectangle, okay? Any questions? No? Okay, next one. A triangular piece of glass have been cut for a stained glass window. Two of the sides are same length and the third side is 2 inches shorter than 2/3 of the length of the other two sides. If the perimeter is 30 inches, okay, pay attention here, unit is inches. what are the lengths of each size? So here we have a triangle, right? And two of the sides are of the same length, but we don't know the exact length, right? So we can use a letter X to denote the length of either side. And the third one is 2 inches shorter than 2/3 of X. So this means the third side is 2/3 times X minus 2, right? Okay, so here at X, denote how to write this? Note one of the two sides that equal, or denote the length. Unit is inch. So here we know that the perimeter is 30 inches. So that means X plus 2/3 of X minus 2 is 30 inches, right? So this gives us 2X plus 2/3 of X equals 32. So this means 8 times 1/3 times X is 32. And this gives us X is 12, right? So we know this one is 12, this side is 12, and we need to calculate the third side. This is 2/3 times 12 minus 2, which gives us 6. Okay, so the conclusion is the length of the thighs are 12 inches, 6 inches. Oh, sorry, we are running out of space here. Okay. Any questions? No? Okay, let's see question 8. Okay, question 8 is a very simple pricing problem. Okay, last time we have already solved a question like this. So if you're still not very comfortable with this, please write this in your error book. Okay, to solve this, let's look at what I'm looking for here. You're looking for the original price of the fridge, right? So we can use a letter X or P. Sometimes if you're looking for price P, it's better to use a letter P. That P denote the original price. Okay, that P denotes the original price. The unit is dollars of the fridge. Right? And as long as we can solve P, we'll get the original price of the fridge. So what we know here, we know that the price has been reduced by 5%, right? So that means reduced by 5% means P times 1 minus 5%, right? Do you understand this? Or if it's not very clear to you, it's actually P P is the original price, right? Reduced by 5%, that means reduced by 5% of P. Is this clearer now? P reduced by 5% of P equals the current price, right? Current price is 1045. Okay, I'll say it again. Original price is P. P is reduced by 5% of original price equals 1045, right? Understand? Okay, so this gives us, because P here is a common factor, so we can put in front according to the distributive law, right? So this is 1 minus 5% in brackets equals 1045. Okay, so here P is, okay, let's write one more step for you. 1 minus 5% is 0.95 P, right? So here P is 1045 over 0.95 means 95 over 100, right? So 1045 divided by a ratio equals this number times reciprocal of the ratio, right? So you can simplify these two numbers, which is 1 here, and then you will get 95, so 11 here, right? And here this result is 1100, and the unit here is dollars. Okay, so we can make the conclusion here. The original price is $1100. Okay, any questions? All right, if you have no questions, let's look at question 9. Question 9, 10, 11, 12, 13, 14, 15, and 16 are all traveling distance problems. So to solve such problems, it's better to draw a sketch to illustrate the problem. This will help you to understand these problems, okay? So my suggestion is, if you are not quite understand this problem, it's better for you to draw a sketch. Okay, let's have a look at question 9. Mike starts out 1.8 kilometers in front of Kim, and they both start moving towards the right at the same time. So this tells us, suppose this is Mike, and it travels towards the right. And it starts 1.8 kilometers in front of Kim. So Kim is behind, right? So this is Kim. Also, he's traveling to the right. And the distance between them here is 1.8 km. What else do we know? Mike moves at 1.2 meters per second. So Mike's speed is 1.2 meters per second. Kim's moves at 2.1 meters per second. So we also know their speeds, right? And asks you to calculate how long will it take for Kim to catch up with Mike. So by the meeting point, there is a meeting point, right? Suppose this is a meeting point. because Kim travels faster than Mike, so eventually Kim will catch up with Mike, right? By the time they meet here, we also know that the distance traveled by Kim is 1.8 kilometers more than the distance that Mike travels, right? So here we use a letter T because we are looking for a time here, right? So let T denote the time taken. Okay, of course, you need to specify the unit here. Okay, we use seconds here because all the speeds are in meters per second. So here we use second. Let T denote the time taken for Kim to catch up with Mike. Okay, so according to our analysis, by the time they meet here, the distance Kim traveled is 2.1 times T, right? Because we know that distance equals speed times time, right? So this is Kim's distance. And Kim traveled more than Mike, right? So the distance Kim traveled minus the distance Mike traveled, which is 1.2 times T. The difference is their initial difference, right? Which is 1.8 kilometers. Because here we're using meters per second. Meters per second times a second is meters, right? So we need to convert 1.8 kilometers to meters. So that means 1800 meters. So this means 0.9 T is 1800. That means T is 1800 times 0.9 is actually 9/10, right? Which is 2000 seconds. So we can make the conclusion here. It will take him 2000 seconds to catch up. Okay, any questions? No? Okay, let's see the next one. Two people start out 200 meters apart from each other and start moving towards each other at the same time. So this time, they start out 200 meters apart. Okay, suppose this is 200 meters. And we have a person move this way and another person moves this way, right? One person is traveling at 1/3 of the speed of the other person, and they meet after 48 seconds. Okay, suppose this is where they meet. So after 48 seconds, they meet. What was the speed of each person? So here we want to find the speed of each person, right? So it's better to use a letter to denote one of the speed, right? Okay, so let's use a letter V. Let V denote the speed Okay, unit is meters per second because here it uses meters and seconds. So it's more convenient to use meters per second here. That V denote the speed of the faster or slower person. Either one is okay, right? How about the fast person? Okay, so this is our faster person, right? So the slower person is moving at 1/3 of the speed. That means he moves at 1/3 v, right? Okay, by the time they meet, the total distance they traveled is 200 meters, right? So that means the distance traveled by the fast person, which is v times 48 seconds plus the distance traveled by the slower person, which is 1/3v times 48 equals the total distance they have traveled, which is 200, right? So this gives us 46v equals 200, correct? And we can easily solve that v is 200/46, which can be simplified to 25/8. Unit is meters per second. This is a fast person. How about the slower person? Slower person travels at 1/3 of v, which is 25/24 meters per second, right? So now we can make the conclusion here. The faster person moves at 25/8 meters per second. The slower person 25/24 meters per second. Okay, any questions? No questions? All right, let's see question 11. Two boats start at the same point. One boat starts traveling to the east at 50 miles per hour, and 2 hours later, the second boat starts traveling to the east at 80 miles per hour. Okay, so this time they start at the same time, at the same point, right? Not at the same time. Okay, suppose this boat travels at 50 miles per hour. And the faster boat travels at 80 miles per hour, right? This is 80 miles per hour. And eventually, because the second boat travels faster, so eventually this will exceed the slower boat, right? And we also know that at some point in the time, the faster boat will be 140 miles in front of the slower boat. Okay, so at some time, they are 140 miles apart. Okay, and it asks you to find how long has each boat been traveling when this happens. Okay, suppose we use a letter T to denote this time. So let T denote the time. Okay, the unit is hours. Let T denote the time that so who starts first? the slower boat starts first, right? So we can use t to denote the time that the slower boat traveled. Okay, suppose this boat traveled t hours. And 2 hours later, the second boat starts traveling. That means the second boat traveled for t minus 2 hours, right? So here we have the equation. The difference between these two boats is the faster boat has traveled 80 times t minus 2, minus the distance that the slower boat has traveled, which is 50 times t, right? Difference is 140. Now we can solve for t. So this gives us 30t equals 300. Of course, t here is 10 hours. This is the time that the slower boat traveled, right? How about the faster boat? Faster boat traveled for t minus 2, which is 8 hours. So the conclusion is the slower boat traveled 10 hours. Faster boat has traveled 8 hours. Okay, any questions? No questions? Okay, let's see question 12. Joey and Natasha start from the same point and walk in opposite directions. Okay, this time they start at the same time and they walk at opposite directions. So suppose this is Joey and this is Natasha. Joey walks 2 kilometers per hour faster than Natasha. After 3 hours, they are 30 kilometers apart. So here, after 3 hours, they are 30 kilometers apart. How fast did each walk? So we want to find the speed of each person, right? So we can use a letter V denote. Okay. For speed, we usually use letter V, right? Because V stands for velocity. Let V denote whose speed. You can use V to denote either Joey or Natasha's speed. So we know that Joey is faster, so let V denote the slower person. Let V denote Natasha's speed. Unit is km per hour. So Natasha moves at V. And how about Joey? Joey walks 2 kilometers per hour faster. That means Joey's speed is V plus 2, right? So by the time they are 30 kilometers apart, how much distance has Natasha traveled? She traveled V time 3 hours, right? How about Joey? Distance Joey has traveled is v plus 2 times 3 hours. And the sum of these two distance is 30, right? This is our equation from which we can solve for v. So this gives us 6v plus 6 is 30. So here we know v is 24 over 6, which is 4 kilometers per hour, right? So what is v? V is Natasha's speed. So we know Natasha travels at 4 kilometers per hour. How about Joey? Joey traveled at v plus 2, which is 6 kilometers per hour. Okay, so these are their speeds. So the conclusion is Natasha walks with 4 kilometers per hour, while Joey 6 kilometers per hour, right? Okay, any questions? No? We're okay, right? Okay, let's see the next one. Nick and Chloe left their campsite by canoe and paddled downstream at an average speed of 12 kilometers per hour. They turned around and paddled back upstream at an average rate of 4 kilometers per hour. The total trip took 1 hour. After how much time did campers turn around downstream? So again, it's better to draw a sketch to illustrate this problem. So suppose this is downstream. Okay, when downstream, you traveled at 12 kilometers per hour, right? Because the stream now is in favor of you. So usually you travel faster downstream. And at some point, they turn around, right? And then travel upstream. And this time they are against the stream. So usually you will travel slower, which is 4 kilometers per hour. This is their speed, right? So now you want to find after how much time did the campers turn around downstream. This means you want to find time t they traveled downstream, right? So here we use a letter t to denote the time. Okay, the unit is hours, right? Because all the unit for speed is kilometers per hour, so it's better to use hours as the unit of time. Let t denote the time they paddled downstream. Okay, so is there any equality relationship here? Okay, the equality relationship is apparently the distance they traveled downstream equals the distance they traveled upstream, right? Let's write it here. Distance traveled downstream equals the distance traveled upstream, right? Because it says they paddled back to the original point here. So what is the distance traveled downstream? Distance traveled is speed times the time taken, right? Okay, so what is the time taken for them to travel upstream? According to the story, the total trip took 1 hour. So that means it took their 1 minus t hours to come back, right? So here, distance traveled upstream is the speed times the time, right? All right, this is the equality sign. Okay, distance traveled downstream is 12 times t, and distance traveled upstream is 4 times 1 minus t, right? And this gives us 12t equals 4 minus 4t, and 16t equals 4, which gives us t is 0.25 hours, right? So now we can make the conclusion. Pedal downstream for 0.25 hours. Okay, have a look at this. Any questions? No? Okay, let's see question 14. On a 130 kilometer trip, a car traveled at an average speed of 55 kilometers per hour and then reduced its speed to 40 kilometers per hour for the remainder of the trip. The trip took 2.5 hours. For how long did the car travel 40 kilometers per hour? So again, it's better to draw a sketch to illustrate the problem. So first of all, the car traveled at an average speed of 55, right? And then it reduces speed. For example, it reduces speed here, and then travels the rest of the distance with 40 kilometers per hour. Okay, we know that the total distance the car traveled is 130 kilometers, right? And it asks you to find how long did the car traveled 40 kilometers per hour. Okay, suppose here the car traveled for t hours, and for the first segment, the car has traveled for how long? For 2.5 minus t, right? Because it says here the trip took 2.5 hours in total. So if this is t here, then here is 2.5 minus t, right? So this sketch illustrates the whole problem here. Again, if you want to find the time taken for the car travel at 40 kilometers per hour, it's better to use a letter T denote this time. Okay, again, the unit here is hours. That T denotes the time taken for the car to travel at 40 km per h. Then according to the sketch, we know that the total distance traveled is 130, right? Total distance traveled is the sum of these two segments. For the first segment, velocity is speed is 55 times time taken, which is 2.5 minus t. And the second segment is speed is 40 times time used, which is t, right? Sum of these two segments is 130, right? So this is our equation from which we can solve our t. So this gives us 137.5 minus 55t plus 40t equals 130, right? And then 15t equals 7.5. Then we can solve t is 0.5 hours. So now we can make the conclusion. The car traveled at 40 km per hour for 0.5 hours. Okay, any questions? No? Okay, let's see the next one. Two bike messengers, Jerry and Susan, ride in opposite direction. Okay, ride in opposite direction. Jerry and Susan. If Jerry rides at the rate of 20 kilometers per hour, okay, Jerry 20 kilometers per hour. So let's make up the sketch. At what rate must Susan ride if they are 150 kilometers apart in 5 hours? Sorry, I draw this wrong. They start at the same point and ride in the opposite direction, right? Should look like this. Suppose this is Jerry and this is Susan. And Jerry rides 20 km per hour. Susan's speed is unknown. Okay, after 5 hours, they are 150 kilometers apart. And we want to know Susan's speed, right? So here we use letter V, denote Susan's speed. Unit is km per hour. So what we know here is total distance they traveled is 150 kilometers, right? So distance Jerry traveled is 20 kilometers per hour times 5 hours. Distance Susan traveled is V times 5 hours, right? And sum of these two distances is 150. From this equation, we can easily solve our V, right? So this gives us 5V equals 50. So V here is 10. Unit is kilometers per hour. Okay, so the conclusion is Susan's speed should be 10 kilometers per hour. Okay, any questions? No? Okay, let's see the next one. Running at an average rate of 80 meters per second, a sprinter ran to the end of the track and then jogged back to the starting point at an average of 3 meters per second. The sprinter took 55 seconds to run to the end of the track and jog back. find the length of the track. This question is very similar to the question 13, right? First, travel downstream and with a faster speed, and then travel back at a slower speed. So this time, this sprinter runs to the end of the track and walks back to the original point, right? So if we draw a sketch, first, the speed is 8 meters per second, then jogged back at a speed of 3 meters per second, right? And you want to find the length of the track. Of course, you can use a letter X to denote the length of the track, right? Okay, so let's try this. Let X denote the length of the track. Okay, unit is meters. Okay, so is there any equality relationship in this question? Okay, note that the total traveling time is 55 seconds, right? So what is the time traveled in the first segment? It's X over the average speed, which is 8, right? Okay, this is the first segment. How about the second segment, which is walking back, right? Time used is X over the average speed, which is 3, right? This is the total time taken for the sprinter to finish a return trip. And we know that sum of these two times is 55, right? Okay, now all you need to do is to solve for X here. Okay, the common denominator is 24. So here we have 24, 11x. This equals 55, right? So x here is 55 times 24 over 11, which is 120. Unit is meters. So what is x here? X is the length of the track, right? So when we get x, we solve the problem. So the conclusion is the length of the track is 120 meters. Okay, any questions? No? Okay. The rest of the questions are all number questions. Okay, let's look at question 17. Sum of 3 consecutive even integers. Okay, pay attention to the word here, even. What does this mean? What are even numbers? Even numbers are 2, 4, 6, 8, 10, etc., right? These are called even numbers, which can be divided by 2 without any reminders. Okay. All that we know that the sum of 3 consecutive even integers is 276. And it asks you to find integers. So let we use a letter X, denote the smallest one. You can also use it to denote the largest one. Does not matter, right? So let X denote the smallest even integer. So that means the next integer will be, okay, suppose x is the smallest one. Next integer, because they are consecutive ones, right? So next integer would be x plus 2, right? Pay attention here, it's not x plus 1. X plus 1 is the next integer, not the next even integer. You can easily see here the difference between two consecutive even integer is 2, not 1, right? So next consecutive even integer is x plus how many? 4, right? Okay, so this is a sum of 3 consecutive even integers. And we know that the sum is 276. Then from this equation, we can easily solve the 3 numbers. So this gives us 3x, no, not 3x. Yes, 3x plus 6 equals 276. And x is 90, right? So we can make the conclusion the 3 numbers are, okay, smallest one is 90, and next one is 90 plus 2, which is 92, right? Largest one is 92 plus another 2, which is 94, right? Okay, any questions? No? Okay, let's see question 18. Find 3 consecutive even integers. Okay, again, these are 3 consecutive even integers, such as 2, 4, 6, 8, 9, 10, right? Sorry, 2, 4, 6, 8, 10. Okay, this time the sum of the first 3 times the second and 4 times the third is 2, 6, 2. Okay. Again, this time we use letter X, denote the smallest number of the 3. Then next number is x plus 2, right? And the largest is x plus 4, right? Okay, these are the 3 numbers. And we also know that sum of the first, which means x, 3 times the second, which is 3 times the second, plus 4 times the third, 4 times the third. Third one is x plus 4, right? Sum is 262, right? This is our equation from which we can solve for our x. So this is 8x plus 6 plus 16 is 262, which is 8x is 24 and x is 30, right? So the conclusion is the numbers are, okay, first one, 30. Next one, plus 2, which is 32. Next one, plus another 2, which is 34, right? Any questions? No? Okay. Question 19. The sum of 2 consecutive multiples of 7. Okay, this time there are 2 numbers. Both of them are multiples of 7, and they are consecutive multiples of 7, right? Such as 7, 14, 21, etc., right? Find these multiples. So if we use a letter X, denote the smaller one of the two. The other one would be how many? Because there are two consecutive multiples of 7, so the next one would be x plus 7, right? Understand? We have no questions here, right? Okay. And we also know that the sum of the two numbers is 77. So that means x plus next number, x plus 7 equals 77, right? This means 2x is 70. So x here is 35. And the conclusion here is the two numbers are 35. Okay, 35 is the smaller one, right? Next one is 35 plus 7, which is 42. Okay, any questions? No? Okay. Question 20. The sum of three consecutive integers is 306. What is the largest integer? So here we only want to know the largest integer. So we can use a letter X denote the largest integer of the three numbers. Okay, and as long as you solve X, you get the largest integer, right? Okay, so we know that the largest one is X. How about the one in front of X? It should be X minus 2. Sorry, X minus 1, right? Because they are three consecutive integers, such as 1, 2, 3, 2, 3, 5, something like that. 2, 3, 4, sorry. Okay, how about the smallest one? Smallest one would be X minus 2, right? Okay, we also know that the sum of these three numbers is 306. Okay, so this gives us 3x minus 3 equals 306. So x here is 101, right? So we can make the conclusion. So the largest integer of the three is 101, correct? Okay, so these are the solutions to the problems here. Okay, have a look at these. If you have any questions, let me know, okay? And please do remember to put any errors you feel worthy onto your error book.